Welcome to the Introduction to Computing in C++ of the Diverse Node Mobility Front-End Development Program. Today we will be discussing Chapter 3, Part 2 that talks about parameters. Okay guys, so going to share my screen to you. Alright, so now we have default parameters here. Okay, so we are now going to rewrite our grid function to make it more flexible. We want it to first be able to emit any grading, not only the one predefined in the source code, and be able to emit the grading more than once on the invoker's demand. So this means that our new grid, this is how we name the new function, has to have two parameters intended to first store the grading, and second is to store the number of grading repetition. So the complete function is along with the short main function here is on the right. Right, so now if we are going to run this code in our online IDE, if I will copy this and paste this on my Edge Interactive Sandbox. So here, so we have the new grid. This is a function, and this function is to grade times on how many times we will grid the user. Okay, so before we run this new grid, take a look at the main function. So here we have called the new grid function, and as you can see, it will prompt the high, and that will be equals to 5. So as you can see, the parameter is string, then grid, then int, then repeats. So as you can see, okay, we have declared here a for loop. Okay, so we have int I is equals to 0, and then I, which is the initialization, is less than repeats. And then I increment, and then C out, then grid, and then we have the string grid, which is high here, and then the new line. So we have the repetition is equals to 5. So if we are going to run this, then it will probably give us a high 5 times. Okay, so we have our output here. Right, so let's have the next line. Okay, so the default parameters as a simple example. The new function makes our life easier, but we want more from it. We have learned that most of our users require only one greeting at the same time, probably due to the average size of their egos. This may mean that we could use the following form of greeting more often than others. So we have the new greet function, and then we have good morning, then 1 times 1. So we may just want to omit the 1, hoping that the function will be smart enough to guess what we are going to do. Is it reasonable to expect that any function will be able to behave in such a convenient way? The answer is yes, but we have to inform it first that some of the invocations will not specify all the expected parameters and indicate which value should be used instead of the absent ones. This mechanism is called default parameters, and we will present its rules by modifying our previous function slightly. We can modify the second formal parameters declaration by using a phrase equals value to signal that we want the compiler to assume that the default value for the parameter when we omit it during the invocation if we declare the function in the following way. So we have here the function new grid string grid, and then int repeats is equals to 1. So the compiler will treat the one parameter invocations like this one. So we have new grid, then hello, as if they were explicitly written as follow: new grid hello, then 1. Then now look carefully at the example on the right here. So take note of the different form of the invocation, the program will produce the following output. So first we have hello to hello, and then good morning, and then we have hi. As you can see, the explicit specifier parameter value invalidates the default value. Okay, guys, let us run this in our online IDE. So here we have the main function. So we have hello in 2 times and then good morning. So it is default as 1 and then hi. Okay, so it is indicated as 1. So we have hello, hello, then good morning, and then hi. Okay, so let's have the third slide. So you might want to ask now if it is possible to have more than one default parameter in one function. If we may choose the default value not only for the repeats parameter but also for the grid, yes, it is possible. Here's an example of how to do it on the right. So here we have the new grid here and we have the string. Okay, so we have um, declare the string in the new grid function, which is equals to good morning, and it repeats is equals to 1. So we also declared here the value of the times of the repetition. Okay, then we declare the for loop int I is equals to 0, I is less than repeats, then I plus plus. So we have C out, then greet, then end line. Okay, so take a look at the main function, which is equivalent to new greet hello, and then this is equivalent to 2, and then new greet, then hi is equals to 2. So you might think what would be the output for this. Of course, this would be probably this would be hello, 2 times hello, and then 1 hi, and then 1 good morning. So let us try this on our online IDE. So, so we get the expected output, which is 2 times of hello, and then 1 hi, and then good morning. So as you can see, we don't have any parameter here because we already declared the default parameter here. So if you use the empty parameter in the main function, then it will call or it will find the default parameter which is declared in the new grid, and that is a good morning in 1 times. Okay, so this mechanism is useful, but to take full advantage of it, you must not forget about the following limitations. First, the order of the parameter is very important, in contrast to regular non-default parameter, which may be in virtual any order. Intuitively, we can say that non-default parameters must be coded before the default ones. The compiler won't be able to identify the parameters otherwise. If more than one parameter is declared with a default value and at least one actual parameter is specified in the invocation, the actual parameters are assigned to their formal counterparts in the same order in which they are listed in the function declaration. This means that you are not allowed to use a default value for the first parameter and specify an explicit value for the second. Okay, so if you want to run that in your NetBeans, Apache NetBeans, you can download this file or even copy it and paste it in a new file. Okay, so let's have the inline function. Okay, so let's first discuss the anatomy of function invocation. So far, we have been using the term function invocation without going into detail. We have simplified, assumed that the invocation do their job in an automatic or magical ways, as a developer used to say automatically. It is now time to fix this to explain how this mechanism works. Take a look at the example on the right. So here we have the function of the invocation here example. Okay, so we have the function name function. All right, so we have the function name function here. Okay, so first that is the first function, and the second function is main function. Okay, as you can see, we have the in parameter inside the parameter inside the parentheses, and we have the parameter then times 2. So in the main function, we have declared variable var, and that is equals to 1. And then we have var is equals to function, which is this one, and then var. So we have 1. And we have another, this is in 3 times. So what do you think is the expected output for this? So if you are going to take a look at here, the parameter, the function is equivalent to var, right? So if var is equals to 1, then we are going to have this, and that is times 2. And if 1 times 2 is equals to 2, then times 2 is equals to 4, then 2 times 2, 4 times 2 is equals to 8. So we will definitely get the value of 8. So going to copy and paste. All right, so here going to run this program, and then all right, so we can get the expected value or output 8. Okay, so there is a function that takes its argument, multiplies it by 2, and returns the result to the invoker. The function is invoked 3 times within the main function. Clear enough? Okay, let's keep going. So we are going to look at the code from the compiler's perspective. It reads that the function code, translates it into the machine code, and stores the translated code in a separate place in the memory. But the code cannot be used as is with no extra steps. Each function's code has to be supplemented with 2 important elements. First is the prologue, and the second one is epilogue. The first is the prologue is a part of the code implicitly executed before the function. The prologue is responsible for transferring parameters from the invoker's code and for storing them in the special transient area called a stack. The second one is the epilogue is implicit executed just after the function's code and is responsible for transferring the result of the function and for clearing the stack of the values placed there by the prologue. Okay, so that is the epilogue and prologue. So take a look at the diagram on the right. This diagram illustrates the flow of control during one function invocation from the previous example. All the other invocation will be carried out in the same way. This approach has some obvious advantages. The function code, the prologue, and the epilogue occupy the same memory space regardless of how many times the function is invoked. So it means that the invoking it in this way saves memory and make your program more compact. But one of the most interesting paradoxes of computer programming says that when a code is compact, it cannot be fast at the same time, and vice versa, when the code is fast, it cannot be compact. Of course, it is more of a joke and rather than a scientific law, but in this case, the rule works very well. So try to imagine that our program is going to invoke the function many times. It may mean that you will have to pay a high price for all of those transfers of control and prologue or epilogue executions. So the price is higher when the function is short. This example shows that sometimes in well-defined cases, it would be better to avoid the prologue function epilogue chain and to insert the function's code directly into the invoker's code. Okay, so take a look at the modified diagram on the right. This diagram illustrates another approach to the problem of function invocation when the function is short and fast. And when we expect the function to be invoked very often, it is better and more time effective to write the function code at each invocation. Of course, we will have to pay for that, don't be surprised by the fact that the total code size will be significantly larger than previously. The tactic of compiling function invocations is called function inlining. A function compiled like this is called an inline function. Okay, so if you want a certain function to be compiled and invoked as an inline function, you have to mark it in a special way. You need to precede the function declaration with the inline keyword. Look at the example on the right. So here's the declaration of the inline keyword. We have used this. We have used. Okay, so we have used inline keyword before the function. Okay, so luckily for us, the syntax of its construction has some flexibility. First, it doesn't matter whether the inline function is placed before or after the name of the type. Both of the following lines are syntactically correct. So whether it is written before or after the data type. So second, if you need to use both the declaration and the definition for the same function, it doesn't matter where you put the inline keyword. It is correct to use it in the declaration and omit it in the definition. So it is also equally valid to use it in the definition and omit it in the declaration. Of course, using the keyword in both places is also valid. So let's have the different tools for different tasks. Different tasks require different tools, although these tools have may have exactly the same name. For example, the tool name knife looks different when it is used by a surgeon, a cook, or a serial killer. We said before that we are not allowed to have a variable and function of the same name. It is time to ask if we can have more than one function of the same name. Yes, we can, and it is natural that we may want to have different tools of the same name used to different purposes. For example, we need a function to find the larger of two float numbers. It doesn't look difficult, right? And we will have written this function for you. Take a look at the snippet in the right. So here we have float and we name it max. So you might argue that we could have written the function in a more compact way. We agree with you. It is way too verbose. Feel free to rewrite it in a smarter fashion. So imagine that one day our needs increased and we suddenly wanted to have a very similar function what was able to find the largest of three values. What could we do? Of course, we can make use of the previous function and assuming that we want to find the largest of the A, B, and C variables to do something like this. So x is equals to max, max, then we have parentheses A and B, and we have the C outside the parentheses. What you don't like it, we don't like it either. It's neither nice nor effective. It would be better to forget our old-fashioned and write a snazzy new one that was much more tailored to what we want. It it would also be a good idea to name it like the old-fashioned, I mean, old one, Max here. This name perfectly illustrates the function's role and purpose. Take a look in the snippet on the right. So we have a function here named Max, and the max variable or the name of the function, I mean, describe the function's role and purpose. So instead of writing max A, B, and C, we can write it float A, B, and float C. The mechanism that allows us to have more than one function of a certain name is called overloading, since the one and the same name is overloaded with different meanings. There is one important limitation: all the overloaded function must be clearly distinguishable to the compiler. The compiler cannot hesitate over which of the overloaded variants need to be used in a particular part of the code. Our examples leave no doubt. The choice is simple. If the invocation contains three actual parameters, the second variant is chosen. If there are two parameters, the compiler uses the first variant. Any other variant of the invocation is considered an error. What circumstances does the compiler take into consideration when choosing the one target function, one of the few available? The first is the number of the parameters. For example, if there are three overloaded functions with respectively 2, 3, or 4 parameters, and the invocation specifies two parameters, only the first of the functions may be used as a target. This function is called the best of the candidate. Next one is the parameters type. If there is more than one function with the same name as the parameters, the target function is selected on the basis of the parameters type conformity. Note that the return type is not taken into the consideration, and when the compiler is looking for the best candidate for a certain invocation, this should be obvious to you if you remember that the return value of any type function may be ignored. In this sense, two functions which differ only in the return type are indistinguishable to the compiler. This means that the following snippet is wrong. So this snippet is wrong. Int function int a, then return a, then void in function, then we have. So that is wrong. Okay, so how to find the best candidate? The number of the different data types in the C++ language is significant, so the mechanism responsible for finding the best candidate has to use some simplification so as not to force developers to create a separate function for each different data type. Take a look at the following example. So we have play with number. So we have the data type int x, play with number float x, and then play with number. So we have code it, and then try to answer this question. Which of this two overloaded function is the best candidate for the invocation? So the invocation is 1, and since the parameter is 1, of course this is not a float, it is an integer. Yes, you're absolutely right. It is the first one with the int x parameter declaration. Okay, so we have changed our example a bit. Can you see the differences? Okay, so we have play with number int x, and then another play with number float x. Of course, this is a float. So we are going to call over the two overloaded the function. We are going to call the second one. So which of the function is the best candidate now? You want to say that the second one, it is the second one, don't you? Sorry, you're wrong. There is no good candidate for the invocation. Why? The literal 1.0 is not type float. It is type of double. Really? So the C++ language compiler tries to promote the type of there is no exactly fit. As in our example, obviously a float is not a double. Unfortunately, to be honest, fortunately, the direction of this type of promotion goes from less precise to more precise, not vice versa. It means that any float can be promoted to double, but no double can be promoted or rather degraded to float. In this situation, this compiler will inform you that it is unable to find the best candidate, and the compilations will fail. You have two choices. First, you can write a third instance of the play with number with one parameter type double. Okay, so we can rewrite it not in float, but we can have double. Second, you can convince a compiler that your literal is a float. You can do that just by adding the suffix f to the number like this. So play with number 1.0, then float. So in order for us to make this float, then we will just add f at the end. So it will become 1.0f. The compiler will be satisfied. Alright, so a new operator, a three argument one. Now is a good time to show you another C++ language operator named question mark then colon. This operator is very original because it requires three arguments. This is how we use it. So we have expression one, and then we have question mark, expression two, then we have colon, and then expression three. So this operator works as follows. So first, calculate the value of the expression one. And then if the calculated value is non-zero, the operator returns the value of expression 2, completely neglecting expression 3. If the value calculated in step 1 is 0, the operator returns the value of expression 3, omitting expression 2. So this means that the result of the following expression is I is equals to I and then greater than 0, and then question mark 1 colon 0 will be calculated in the following. So variable I will be assigned with 1 if its previously value was greater than 0 here, and then 0 otherwise. Note that we can achieve the same effect using the conditional statement. If I is greater than 0, then I is equals to 1, else I is equals to 0. This form is somewhat more extensive, although we cannot deny that it is more readable at the same time. So we can use the new ternary operator. It is worth mentioning that this is the only ternary operator in the C++ language to implement our two-argument max function in a more compact way. So here it is. So rather than writing that into if-else statement like this, if I is greater than 0, then I is equals to 1, and else I is equals to 0. Okay, so we have return A is greater than B, and then we have question mark A, and then colon B. So if you are going to write that in a if-else statement, then we will get the A is greater than B, then question mark A, colon B. Then if we are going to create an if-else statement, then we will have if A is greater than B, then A is equals to A, which A is equals to 0, 1, and then else A is equals to B, where A is equals to 0. Alright, so let's have the next slide. Okay, so the three argument variant can make use of the ternary operator too, although we have to admit that the code on the right is not most readable. Please use the question mark colon operator with caution. It doesn't offer much expressivity, but does destroy a lot of clarity. But it's up to you what to decide too. So as you can see here, this ternary operator. Okay, so we have a parenthesis. We know that the parenthesis is a high priority operator, so all we need to do is just put this aside and just take a look or get the result for this and for this. And after that, then we can get the A is greater than B, and the question mark, then the answer for this, and then semicolon, and then for the answer for the second parenthesis. Alright, so think of this chapter as a digression, but a very useful digression. We are going to tell you about sorting. Sorting is very serious, and many sorting algorithms have been invented so far, which differ a lot in speed as well as in complexity. We are going to show you a very simple algorithm, easy to understand, but also not too efficient. It is used very rarely and certainly not for large and extensive arrays. So we can say that the array can be sorted in two ways. First is increasing, or more precisely non-decreasing, if in every pair of adjacent element, the former element is not greater than the latter. Second one is decreasing. So decreasing, or more precisely non-increasing, if in every pair of adjacent number, the former element is not less than the latter. In the following sections, we will sort the array in the increasing order so that the numbers will be ordered from the smallest to the largest. Here is our array. So we have 8, 10, 6, 2, 4. So that would be the elements in our array. So let us try to use the following approach. We take the first and the second element and compare them. If we determine that they are in the wrong order, the first is greater than the second, we are going to swap them. If their order is valid, we do nothing. A glance at our table confirms that the second version, the element number 1, element number 2 are in the proper order as 8 is less than 10. Now look at the second and the third element. They are on the wrong position. So we have to swap them and let us do it. Okay, so here we have 8, 10, and then we are going to arrange them in increasing order. So first is going to swap 2 and 4, then 2 will go here, and then 4 will go here, and then 4 and 6 will be swapped, and then will be in the proper order, and then 8 and 10. Okay, so we can go further and look at the third and the fourth elements again. It is not what it's supposed to be like, and we have to swap them. So look at the presentation here. Okay. And then now we can check the fourth and the fifth elements. Well, yes, there are two are in the wrong position. So let's have another swap. Okay, so 2 and 10 was interchanged or swapped. Okay, so the first pass through the array is done. We are still far from from finishing our job, but something strange has happened in the meantime. The largest element 10 is obediently went to the end of the array, which is where we want it to be. All the remaining elements from form a picturesque mess, but this one is already home. All right, so we have interchanged 10 and 4. So let's have the next. So now for a moment, try to imagine this array is in a slightly different way, namely like this, 10, 4, 2, 8, 6, 8. Look at the 10 is at the top. We could say that it is floated up from the bottom to the surface, just like the bubbles in a glass of champagne. In fact, the sorting method gets its name from this very same observation. Is called a bubble sort. Okay, so champagne's all gone. So now it's time to get back to the sorting. We do it with pleasure, starting with the second pass through the array. We'll look at the first and the second elements. Oh, a swap is necessary. All right. So now the second and the third elements. Yep, 8 is a bubble and goes up to the surface. So 8 and 6 was swapped. So time for the third and fourth elements. We have to swap them too. Okay, so 2 and 8 were swapped. Okay, so the second pass is finished as 8 is already in place. We started the next pass immediately. Watch and watch the first and the second element carefully. Yes, it is time for a swap. Okay, so 8 and 4 were swapped. So as we can see that 8 is already home, and now 6 needs to find it its place. We will help it out and swap the second and the third elements. Alright, so 2 and 6 was swap or interchange, and 6 needs to find its place. So all we need to do is another swap here by 6 and 4, where the 6 will be on its place. Yeah, so look, the array is already sorted. We have nothing more to do. This is exactly what we wanted. As you can see, the essence of this algorithm is simple. We compare the adjacent elements, and by swapping some of them, we achieve our goal. So we will try to code in the C++ language all the actions performed during a single pass through the array, and then we will think about how many passes we actually need. We haven't analyzed this so far, and we will discuss this more a little later. So how many passes do we need to sort the entire array? So we can resolve this issue in the following way. We introduce another variable. Its task is to observe if any swap occurred during the pass or not. If there was no swap, then the array is already sorted and nothing more has to be done. We declared a variable named swap, and we assign a value of false to it to indicate that there were no swaps, otherwise it will be assigned to true. So here, this is the array to be sorted. This is the auxiliary variable for swaps. And then we need 5 to 1 comparison. Why? Okay, so in order for us to do this, then we will use for loop. And then I is equals to 0, I is less than 4, I plus plus. So we are going to compare the adjacent element, and how to do that is if we have an if condition here, numbers I is less than numbers I plus 1. If we went here, it means that we have to swap the elements. Then ox is equals to numbers I is equals to numbers I plus 1, then numbers I plus 1 is equals to ox. So we hope you can read and understand this program. On the next slide, you can see a complete program enriched by a conversation with the user, which allow the user to enter and print elements of the array. Okay, so first, take a look at this first. Okay, so we have the int number, and then int ox, and then bool swap. So all we know that the value for bool is only for true or false. Okay, so do, then we will decide if we need to continue this loop, and swap is equals to false, no swap occurred yet. And then for we have a for loop, and then int is equals to I is equals to 0, I is less than 4, then I increment. If numbers I is greater than numbers I plus 1, then swap is equals to true, then ox is equals to number I, then numbers I is equals to number I plus 1. Why we do another plus 1? Because that is the clue that is the higher number for the number of the current number to be swapped. Okay, so numbers I plus 1 is equals to ox. Then we will have the while loop. Okay, and then swapped. Okay, so this is a complete code. Okay, so take a look at the editor. Okay, so take a look at the editor. Okay, so as you can see, As you can see, we have a bool swap here. So this will determine if we are going to swap or not, because the bool of value is only for true and false. All right, so the first one, we have a for loop here, and that would be I is equals to 0 and I is less than 5, then I increment. So we are going to print out enter value number and then I plus 1, and then it will only prompt a 5 times since we have a limitation here. Okay, so this will prompt the user to enter the value number 1 to 5. And then the user will prompt it, and it will be read by our compiler from using the cin until on the 5 values. And then after that, we will have the sorting the arrays. And how to do that, we will use the do while loop. So as you can remember that the do while loop is um, determining if we are going to swap that or not. So let's take a look at the requirements if we are going to swap it. So if a for loop is I is equals to 0, then I less than 4, and then I increment. Then if number is greater than numbers I plus 1, then swap is true. So that is the requirements for us to do the swapping. All right, so x is equals to numbers I, then numbers I is equals to numbers I plus 1, then numbers I plus 1, then equals to x. Then while swap. So we are going to print as a result, then while. All right, so here in the last part, we are going to print the result. And how to do that is first we will have the sorted array to be print on, and then here for us to swap it, then we will have a for loop I is equals to 0, then I is less than 5, then I increment. See out, we're going to numbers, then I, what is that, and then see out is, and then end L. So as you can see here, we are going to swap it or sort it using this for loop. Okay, so now let's try to run this program. Okay, so let's have, okay, so that is the sorted array from sorted array increasing. Alright, so void, a very exceptional type. We have seen the unusual type called void in our examples a few times. We have used it to indicate that the function either doesn't return a result or does not expect any parameters. According to the following function prototype, void nothing at all and void, the function should be invoked without parameters and result no result. And the return no result. This is how we should invoke it, nothing at all and then void. So there is no parameter inside the parenthesis. Okay, so despite the fact that the void type does not represent any useful value, it is possible to declare pointers to this type as in the following example. So here we have pointer, void, and asterisk PDR. You may ask how to use a pointer that points at nothing, and then ask why have such a pointer at all. This kind of pointer, which is of type void asterisk, is called an amorphous pointer to emphasize the fact that it can point to any value of any type. This means that the pointer of type void asterisk cannot be subject to the reference operator, so you must not write anything like this. Asterisk PDR equals 1. So if PDR was of type void, asterisk PDR would be of type void, and the assignment of a value of type int would be prohibited by the compiler. However, pointers of type void asterisk are very useful when you need to have a pointer but don't know what it may be used for in the future. So as soon as it becomes clear, the pointer can easily be converted into another pointer of the desired type, which is always possible and does not cause any loss of accuracy. So void pointer is very useful for us to see, for us to use as an auxiliary pointer. Okay, so in the example we have seen so far, memory management has taken place outside of our consciousness. Parts of memory we have used to store values were hidden behind the names of the scalars and arrays. They appeared as soon as they have been declared and disappear when our program ended its operation. All work associated with memory allocation was organized by the compiler, and we did not care how it worked, and this is exactly how it should be. High-level languages and their compilers are designed to exonerate the developer's mind of such responsibilities. It frequently happens that the developer wants to have full control over how much memory is used and when exactly it is used. This is especially important when you don't know in advance what the size of data to be processed is. To manage the allocating and freeing up of memory, the C++ language gives us two specialized keywords. Here are both of them for you. The new keyword is used to request the creation of the new memory block when the allocated memory is no longer needed and or utilized. It would be a good idea to return it to the operating system. We do this with the delete keyword. So here's the new keyword. We have the new and the delete. So this new keyword is used to request the creation of the new memory, and the next one is the delete keyword to allocate the memory if no longer needed and or utilize it. So we have the new keyword reserve, that is the reserve keyword. So the new keyword that performs this first test can be used in the following way. First, it needs precise specification regarding the entity being created. It must be expressed as a type description, and if the created entity is an array, the size of the array must be given to. The next one is the new returns a pointer of type confirming to the newly created entity. The third one is the new allocated memory area is not filled or initiated in any way, so you should expect it to just contain garbage. So here float asterisk array is equals to new float, then 20 in count is equals to new int. So the first describes the new return pointer, and we also have a new pointer here. As we all know that the new keyword request for the new memory allocation. Okay, so when we no longer need the memory, we can relist it or free it using the delete keyword in the following way. So here we have delete, then have array delete count. We are going to use the bracket if it is an array, and we just set write delete if it is integer. So first we use the delete bracket, open and close bracket form if we want to free up the memory allocated for an array, and otherwise we can use delete. You can only release the entire allocated block, not a part of it. After performing the delete function, all the pointers that point to the data inside the freed area become illegal. Attempting to use them may result in an abnormal program termination. Of course, you already deleted and you are going to use it. It will probably give you an abnormal program termination or an error. Okay, so now we are going to show you a complete, albeit not very useful program that demonstrates the use of both keywords. First, we declare the variable called ARR here. Okay, so we have ARR, which will point to the data of type float. The pointer's types is float, as there is no value is initially assigned to this variable. So we use the new keyword here to allocate a block of the memory sufficient to store float consisting of 5 elements. And third, we make use of the newly allocated array, to be precise, a vector. And next, we release it using the delete keyword, which we have declared here. So pay attention to the fact that the pointer returned by new is treated as if it is an array. Surprising? So the handling of the dynamic array is no different than using regular arrays declared in usual way. So we owed it to the bracket operator, open and close bracket operator, regardless of the nature of the array. We can access its element in the same way. Okay, so being able to allocate the amount of memory that is really needed lets us write programs that can adapt themselves to the size of data currently being processed. So let us go back to the bubble sort algorithm that we showed you earlier. This program assumed that there were exactly 5 numbers to sort. This is obviously a serious inconvenience. It may happen one day that we want to sort 10,000 numbers or possibly even hundreds of thousands. You can of course declare an array of a maximum predictable size, but it would be unreasonable. A much better way is to ask the user how many numbers will be sorted and then allocate an array of the appropriate size. Let us try to start with a simpler example. In the following program, we allocate an array containing 5 elements of type in, set their values, sum them up, and finally release the previously allocated memory. As you can see, we have used the new keyword here. So these are prompting to request new memory allocation for the 5 element array. And then after summing them up, of course, we already get the result, and then we are going to free up the memory allocation. Okay, so the improved bubble sort program goes here. So take a look in the example. We are going to discuss and analyze it in the editor later. So we encourage you to compile and run the program yourself. All right, so let's take a look in the editor. All right, so here in the editor, we have declared the pointer numbers, and then how many numbers this is in the int type, and we have ox in the int type also. So we have a bool, and that is swap. So we are just going to swap if it is not in the right place. And then here we have a C out, and then how many numbers are going to sort. So here in this program, it will depend on how many number, or the user will input on how many numbers you are going to sort. Okay, so first, and then it will be compiled by, it will be uh, we will have the cin, or it will be scanned by the compiler, and after that, here, as you can see, we have a limitation on how many numbers, so we are going to declare the if statement here. How many numbers is less than is or equals to 0. So as you can see, there will be no negative number or less than 0, and then how many numbers is it will also not greater than 1 million. So are you kidding? If the number or the user input negative number or more than 1 million, then it will print are you kidding. So let's have the numbers is equals to new int. So here we have declared new. As you can see, this is requesting to the compiler to allocate some memory for this. Okay, so we have int and then how many. So remember that this is a variable, and after that it will be enclosed by a bracket after the data type int. And then here we have a for loop. Int I is equals to 0. I is less than how many numbers in I plus plus. So this will determine on how many numbers will be inserted, and then C out, enter the number or the value, and then I plus 1, and then here, okay, so C in numbers I, and then we have the do while loop. Then swap is equals to false if it is on the right place, and for int I is equals 0, I is less than how many numbers minus 1, I increment. If numbers I is greater than numbers I plus 1, then we will going to swap. So swap is true here, and x is equals to number I. Then numbers I plus 1, the numbers I plus 1 is equals to x. So we are going to swap. Okay, so that would be the process for swapping. And then C out and L in the sorted array would be. Alright, so let's try to run this program. Okay. Okay, so remember this is an online IDE, and the disadvantage for this is it only have a limitation time to run. So once again, okay, so we have the sorted array into increasing order 1, 100, and 500. Okay, so let's try another one. Let's interchange the values. Okay, so all right, so here I have chosen three only values, and that is 500, 100, and 200. It is sorted from 100, 200, and 500. All right, so let's have next for this. Okay, so welcome to the module 3 quiz. Okay, so guys, you Okay, guys, so welcome to the Module 3 quiz. And you will answer this in 25 minutes in 10 questions. And after you answer this Module 3 quiz, you will answer the Module 3 test. So thank you, guys. Once again, this concludes the Chapter 3, Part 2 of the Diverse Node Mobility Front-End Development Program. Have a good day. Thank you and goodbye.